Hello. Hi guys, good morning. Welcome back to your video. Ki halchal. I hope you guys are doing good. In this, we're going to see about word subset. Now it simply says that you are given two string arrays, word one and word two. As you can see, word one is an array of strings, and word two is also an array of strings. Again, this is actually strings. As you can see, strings. Now a string B is called as a subset of a string A. Again, make sure, don't apply your brains. Whatever they are defining as a definition of subset, you take that. String B is a subset of a string A if every letter in B occurs in A, including its multiplicity. And they have given the example also that WRR is a subset of warrior because W, R, and R is occurring. That's it. Again, for me, order doesn't matter. Here, there is no definition of order. They're just defining occurrence, right? And all the occurrence, which means if the multiplicity of R is 2, I should have at least 2 R's. That's it. Now, but not a subset of this thing. Why? Because W and R only occurs once. That is the reason WRR is not a subset of world. And they are saying that a string A from words 1, which means words 1 is the actual input, is universal if for every string B in words 2. Again, the biggest point is every string B in words 2, B is a subset of A. So ultimately, I have to just have a check that for words 1, let's say this is one such string. I will iterate on every string in words 2 and then find out if every string in words 2 is a subset of this specific string in words 1. If yes, then a string A from words 1 is called as universal. So this will be a universal if and only if every string actually is a subset of this string. And I have to return ultimately all universal strings. Again, I can return in any order. So very basic naive way, as you must have thought of so far, is that for one input string of words 1, I will have to iterate on all input strings in words 2, check if that is actually a subset in my words 1, let's say words 1 of I, W1 of I. So if I compare it for one input string, what is the time complexity? Obviously, I will have to iterate on all these strings. So that will incur n. Let's say in words 2, I have m such strings. Each string can be of any length. If I go and look at words 2 dot length, I can have 10 to the power 4 string. The length at max can be 10. So, okay, obviously I can go to m strings which can be 10 raised to the power 4. This is for words 2. Words 2. The length itself for one string, because obviously I have to iterate on that string, and when I say iterate, the length of that, it is the word 2 length. Now what? I'll have to compare. Compare what? If I go and check, like tell you this thing, if the word 1 was a warrior and the word 2, that specific word, again, let's say word 1 of I and word 2 of J, was a WRR. So technically this is of length 10. This also can be at max of length 10. But to know if word 2 of J is a subset of word 1 of I will have to check its frequency. That's ultimately what I want. That word 1, like W should occur once, at least once, and R should occur at least twice, which means I will get the frequency out and I can have at max 26 characters because I can simply see that it contains only lowercase English letters. So I can have 26 characters, and then for those 26 characters I will just say, okay, get me the frequency of here, like frequency from here. W occur once, A occur once, R occur thrice, I occur once, O occur once. So is W occurring at least once? Yes. Is R occurring at least two? Yes. Okay, then it is good. So I have to iterate on it, make a hash map of a size 26. When the hash map is made, obviously I'll just make a hash map from here also separately. I can do a pre-computation or I can do computation at the moment also. And after computing or after making it, I'm pretty sure that I can compare it in 26 times. So, oh, although I can do like in the one loop itself, but I can maybe pre-compute it that the corresponding hash map. Thus, for every string, I would just be needing, okay, just get me the 26 hash map length. And obviously, if the length itself is bounded by 10, the hash map also will be bounded by 10 characters. Cool. Now, you went on to every string of length 10, got its hash map. Considering you have also pre-computed the hash map from above, but this is right now you did for one string of words one, right? You have to do it for all strings of words one, which is n. So this will again be 1e4. Again, I also imagined that right now I have pre-computed its hash map, right? This will give you TLE, obviously. This will give me TLE. Sorry, if I go down, yeah, 10 to the power 4, 10 to the power 4 into 10. This will give me TLE. Then what to do? Obviously, the biggest bottleneck is that this is I am repeating it for all the input string in words one. Obviously, this will I have to do because I have to check that if this specific words one string is universal or not, this is universal or not, this is universal or not. That is one thing which I have to do. That is something I cannot get run away from. What is something which I am doing unnecessarily? This is the portion which I am doing unnecessarily really for all the input strings. Can't I just pre-compute this also? But Aryan, how you will pre-compute it? Simple. That if right now I had a job that word 2 of J was WRR, and I was checking this thing. Then another W2 of J would have been, let's say ARRR. Okay, then another W2 of J would have been OWR. So rather than checking, for this also just going through it, and then this also again going through it, then this also again going through it, can't we do a pre? And again, this is I have to do for one W1 of I. I have to do it for all W1 of I. So rather than individually making them go through it, which is giving the time complexity, can I somehow combine all of them? Yes. Why? Yes. Because see, ultimately my aim is that W should occur once, R should occur twice. A should occur once, R should occur thrice, at least thrice. O should occur once, W should occur once, R should occur once. So it's this thing says W occur once, R occurs at least twice. This thing says A occur once, R occurs at least thrice. This thing says O occur once, at least once, W occur at least once, R occur at least once. So with this thing, it will say me W should occur at least once, R should occur at least either 2 or 3 or 1. Okay, at max. Oh, at least 3. It should be there. Why at least 3? Because this needs to be catered against. And then O should occur at least once. W, okay, at least once already covered. A should occur at least once. And then R is already done. So this thing is the ultimate thing which I should be checking. Again, you see what I did? I took the maximum. If I just say I took the maximum of any specific character, and thus this is the final. Again, this can at max of size 26 because now it is taking consideration all the word 2 of J. So now this specific 26 size I have to compare against the hash map from my word 1 of I and see that word 1 of I at least one character, yes. Word R at least 3, yes. O at least 1, yes. A at least 1, yes. Okay. So this is good for my warrior. So this is how I can achieve it. Now what happened? I did a pre-computation. So if I go back, I did a pre-computation for all the characters inside my word 2. I did a pre-computation. So I went ahead on all the characters inside my word 2, which can be M word 2 strings, each string of length 10. So of length 10. So this will take the time complexity of at max 1e5 because this is 1e4. So 1e5 has a time complexity to build a hash map of size 26. When this hash map is built, again, you can build a hash map or you can also take a vector because first size is fixed. So I can take a vector also because vector is straightforward and it takes a lesser time. Again, in general, very less difference in time, but still it will take a lesser time if you take a hash map because of continuous assignment of blocks which you have. Now So when you have built the hash map with this specific time complexity, now just simply do one thing, that whenever you are iterating on word 1 of I for this input string of length 10, build a hash map for this also. Again, its hash map size will be at max of size 10, and just simply compare that whatever you have got from here for the specific size, which means that, okay, as you can see, that W should be once, R should be at least thrice, O should be once, at least once, and E should be at least once. So all that should we make, like, should make sure that this is actually handling, which means that for every character of length 10, firstly firstly I will build a hash map, or you can say a vector. I'll build a vector of frequencies of size 10, which means, as you can see, of size 10, this is actually, I build it of size 10. When this is built, I know that I have one hash map at max of 10 characters, another hash map at max of 26 characters. I just have to iterate on this second hash map, or I can say vector, and check if for this input hash map all the characters are at least that much frequency or not. So when this is done, another operation will be for one such input string, which means this I will repeat for all the input strings of word 1 of I. At max, I will be comparing with this hash map of size 26, of size 26. So this will be the time complexity. Cool. So if I show the code, it will be pretty more simple. Firstly, you see that I iterated on all the string in my words 2. Then for this input string in my words 2, I got the corresponding count. Again, this count is similar to hash map. I used a vector here, but it is similar to hash map. Now, this is, I told you, I have m strings. This step will take at max 10 time. Now, you might say, Aryan, I can have length of 10. That is the reason you are saying it. Yes, true. So if you see back, I have this specific input. You see that I take a hash map and I give it a size of 26. Again, why I'm saying is this as a hash map, as you can see, this helps us to plot the corresponding frequency and ultimately return the answer, which is this input vector, in which the index 0 represents character A, index 1 character B, index 2 character C, and so on and so forth. Now, when I have got the B, I will simply iterate. I will simply iterate on all the characters of size 26 and will maximize for every character what I need. As if you remember back, I iterated on this and tried to maximize. As you can see, R became a 3 because of maximizing the frequency of R out of all the word 2 of J. So this step will take 26 time. So ultimately this step will take m into 26 time. Cool. Now let's go on, and here is my final answer. Then I went ahead with each and every word. I firstly get the hash map of A. So this is A count. Again, if I say it is N, it will be 10, because obviously it will take 10 as a time. But then you might say, Aryan, I also have this specific vector. No, vector is simply a hash map. This doesn't take time as such, right? Iteration on the characters will take time. Okay, coming on back, I will check if this B max is a subset of A count or not. How I will check it? I will have a flag is subset. I will iterate on all the characters and I will check if A count frequency is less than B max, then obviously it is not a subset, because I wanted that A count frequency should be more than or equal to B max. This is B max, this is A count, right? Now coming on back, if it is a subset, then I will push the current A in my answer and I'll simply return my answer. So this step will again take 26 time. So if I tell you the time, as I've already explained, it will be O of n into 26 plus m into 26 in the worst case. And space, as you know that you are using a 26 of space here, this will ultimately take a 26 of space. Again, here also you are building a 26 space again and again. Forget about the answer. This doesn't take like this is not counted as an extra space. So obviously you will take 26 of space, and that is your answer. Cool. I hope you guys got it. Bye bye. Take care. Please like it if you like it. Bye bye.